Welcome to Lab 2. Lab 2 is kind of exciting. With Lab 2, we're going to focus in on climate change. Now, climate change, as its simplest definition, is changes in temperature and precipitation. Those predictable patterns of temperature, the highs and lows from month to month, and then the predictable amount of rainfall or snowfall or whatever the precipitation is supposed to be. Now, for the most part, climate change is this really, really abstract concept. And I say this as an environmental scientist, having studied this, having done research about climate change. It's an abstract thing. It takes a lot of work to really understand what goes into changing those patterns, predictable patterns of temperature and precipitation. Now, I know that one of the reasons why the patterns of temperature and precipitation are changing is because of our greenhouse gases. And one of those gases is carbon dioxide. So in this lab, we're going to focus in on carbon dioxide. And what's nice about this is we're going to be able to tangibly see carbon dioxide and experiment with it and play around with the greenhouse effect, that ability for these greenhouse gases like carbon dioxide to trap heat closer to the surface. So we're going to be able to see and experiment and play with something that's otherwise this invisible gas. We just don't see it. You know, I know that when I use my car, it's coming out of the tailpipe. I understand how it's going to affect that larger system, but even having done all the research, it's really, really hard for me to understand that something's even coming out of that tailpipe that could have this larger effect on our plants and animals and these larger patterns. So today we're going to be able to focus in on that. Believe it or not, you have been taking advantage of carbon dioxide probably every day, and you've been taking advantage of it in the form of baked goods, like breads and cupcakes. Essentially what we're doing is we're manipulating carbon dioxide. When carbon dioxide is released in bread, it stretches and makes those great big holes. When carbon dioxide is released in cupcakes, it makes those cupcakes taste fluffier. So when you're baking, you might use something like baking soda. When baking soda interacts with an acid like vinegar, it's going to release carbon dioxide. Now, those carbon dioxide bubbles are going to make our baked good a lot fluffier. So if you are unable to use some of the more commonly thought of baked substances like eggs and milk in your dairy milk in your baked good, and you're wondering how to make things fluffy, one common way that you will see in vegan baking is to use something like baking soda and some kind of acid like vinegar, because every time these two interact, carbon dioxide bubbles will be released. So in experiment 1, we're going to have quite a few different student-provided supplies. Hopefully you have all of these different items in your house, everything from a candle to the measuring spoons, a teaspoon, and a tablespoon. It's important that we get containers that are of the same style and same size so that when we have these two experiments happening, we can make an accurate comparison. Back here is my cling wrap or my film wrap. And then over here, I have a light source. And the important thing about this light source is that it is an incandescent bulb. This bulb is going to produce a tremendous amount of heat. And after a while, even touching this outside surface, I can feel that it's heating up. We need to make sure that our light source has some heat because we will be manipulating or using that heat in our experiment today. So, as always, I set up my supplies first, make sure that I have everything. That way, once I start following step-by-step procedures, everything is close at hand. So one of the fun experiments that you're going to get to do is a fairly simple, straightforward experiment, but it might take a few attempts to get to work. We're going to measure a teaspoon of baking soda into one of our jars. Now, if you haven't done much cooking or baking, one of the things you might need to know is how to make sure you get accurate measurements. And one piece of advice you'll always hear is to scrape off the top of your container, make sure it's level and straight. This way you have the accurate measurement. In this case, 1 teaspoon. So what I was doing was scraping that right along the top so I have a nice level surface of baking soda. The next thing I'm going to do is I'm going to add 1 tablespoon of vinegar. And this is a liquid, so we want to make sure that when we add this tablespoon of vinegar, that we're paying attention to that meniscus. We want to make sure we have a fairly accurate amount of vinegar. And when I dump this in, it's going to bubble and froth immediately. In one of the previous experiments, you were just getting familiar with how this frothing happens. Once I dump this in, I'm going to give it a little swirl, and then I'm very quickly going to start pouring all of the gas that's released. It looks like I'm pouring nothing from this container into my empty container. Once I have captured all of the gas in this container that will look like it's empty, I will then dump it on top of the candle. So this will happen fairly quickly. There's my frothing, giving it a swirl, and pouring and covering to try and capture as much of the gas as possible without dumping any of the liquid, and quickly dumping and pouring on top of my candle. So hopefully this experiment works for you. It might take a few tries or attempts to get this to work. I want to demonstrate some of the techniques in experiment 2 because as I was reading through them, it didn't seem as intuitive as some of the experiments that we did for Lab 1. So for exercise 2, what we're going to need is 2 containers, and it is important that they're clear glass. We're going to be observing the temperature change, and so we need to be able to see inside of our container in order to measure the temperature change. So I'm using the 2 clear jars from my first experiment. When you are choosing the container that you're going to use for this, make sure that you have a container that will fit your measuring device. If you're using the yellow thermometer that came with your kit, you're going to need a much taller container than what we have here. I have 2 digital thermometers, and so I know that these digital thermometers can fit inside of those environments without sticking out of the top. So we have our 2 clear glasses. And the next thing that we need to do is we need to prep our clear glasses. In this container, I have a mixture of water and soap. And what that water and soap mixture is going to do is essentially keep condensation from forming on the sides of my jar. So I dip my paper towel into my soapy water. I'm just going to wipe around inside of these containers. These containers are essentially going to be little planets. And we need to be able to read inside to see how the temperature is changed inside of these little planets. All right. My planets are all wiped down, so I won't have condensation. The next thing that I want to do is I want to label my 2 jars. So this is going to be Model 1. And I'm using Sharpie marker in order to label my 2 jars. The nice thing about Sharpie on glass is that when I am done with this experiment and washing my jars, I can just use some of that alcohol from the previous experiment to remove the Sharpie. So I've labeled my 2 containers, Model 1 and Model 2. The next thing that I need to do is I need to give one of my containers, I need to give one of my planets an atmosphere. And that's where our film wrap is going to be so important. This plastic film wrap is essentially going to mimic the greenhouse gases that we have here on Earth in our atmosphere. So I'm going to fit it to the jar. If you are using one of these canning jars, this metal lid works really nice for sealing things in place. It's okay if you're not using canning jars. Just use a really nice tight rubber band to fit around the edge. We want to make sure that that plastic wrap makes a nice strong connection to our jar. Now I'm going to trim off some of this excess because I've got quite a lot of excess plastic wrap. And once I've trimmed off this excess plastic wrap, the next step is to move these into a really sunny location. So I'm going to gently remove my greenhouse gases. I'm going to remove that bit of atmosphere. I'm going to transport these items to my sunny location. When I get to my sunny location, I'm going to put the thermometers inside of the glass containers. I'm going to seal up Model 2 with enough slack so I can hit that button on my digital thermometer. Or if you're using the thermometer that came with your kit, you will have taped it onto a piece of cardstock, and you will be placing it away from the sunshine in such a way that you can read the measurement on the lines. We're going to place it into those sunny windows, let it sit for the amount of time specified in the protocols, and then we're going to take our measurements. We'll see what happens when we have those greenhouse gases and how that affects our little mini plant. Now, essentially, the first two experiments, experiment 1 and 2, are building you up to experiment 3. You're getting some hands-on experience with independent variables, dependent variables, and remembering back to what you learned in Bio 103 or an introductory biology course, lecture course, the dependent variable is our data. It's what we are measuring. The independent variable is what we are messing with. It's generally whatever thing we're altering or changing or what we want to know could potentially cause or lead to or is correlated with the response. Our control variables will be everything that we hold constant in an experiment. So that would be having 2 containers that are exactly the same, making sure to use the same measuring device in both of those containers, and making sure that everything is the same, including how I treat both of those, the fact that it's room temperature, and the fact that I'm doing all of this on the same day and not trying to do a little bit of the experiment on Monday and then do a little bit on Tuesday. Things could be different on Tuesday as opposed to today, Monday. So our control variables will be everything that we hold constant as the researcher, as the scientist. There will be so many control variables in our experiment. We want to make sure that our independent variable, what we messed with, whatever it is we're altering, we want to make sure that that is what leads to our response and not anything else in the environment. Our experimental group is the group that is getting our treatment. It is a group that we are messing with, the thing that we are messing with, or the container of animals if we're doing animal research. Our control group is the group where we're not messing with it. It is the thing that we want to stay constant. It's going to be our baseline so that we can compare our experimental group with our control group. Our control group is going to show us the amount of change when we compare experimental group to our control group. So hopefully in the last few experiments you started to get a feel for independent variable, dependent variable, experimental group, control group, and then all of those control variables, those things that we're going to hold constant, so we know that what we messed with led to the response in our experiment. For experiment 3, you're going to take all of that knowledge and your experience with the different supplies, and you're going to come up with your own experiment. Essentially what you get to do is mimic some things here on Earth. And one of the things that got me really excited was thinking about ice. I love being in the Upper Peninsula, Michigan. I love winter. I love the mountains and snow. I know this seems really weird, and but it's true. I love all of this wintry, icy stuff. One of the things I love about ice and snow is that it reflects sunlight, and that can change the conditions. So I took my 2 ball jars here, my 2 canning jars. I put that tin foil, that tin pan that we used in Lab 1 for our fuel source, for our burner source. I took that and I flipped it upside down. Essentially, this is going to act like a great big lake with a lot of ice on it. I turn on my sun, and now I'm going to let this run for about an hour. I'm going to let it run for about an hour. I'm going to record the change in temperature in these two containers to give me a sense of how much energy is reflected from sunlight hitting on ice, like our Great Lakes in the wintertime, versus on land in my second container. So this is just one of the things that I wanted to play with because it's near and dear to my heart. I look forward to seeing what you might experiment with. I know that there's some ideas in the lab protocols. As always, you know how to reach me. Email, send me short videos, send me pictures, or show up at the Zoom office hours on Wednesdays from 11 to noon.